Welcome to this deep dive, part of the Data Zen AI podcast by the Data Zen community. We are really excited to get into this one.
Yeah, absolutely.
Because if you are a project manager or, a delivery manager, a team lead, product manager, basically anyone in charge of building things, you are going to want to block out some time for this.
You really are. It's a critical topic right now.
It is. We are tackling a reality that is, it's currently keeping people up at night across the entire tech industry.
Right.
We are looking at a theme we're calling Why Most AI Startups Fail Lessons for Project Leaders. And the reason we're doing this is that AI is just completely inescapable right now.
It's everywhere.
Right. It's on every magazine cover. It's the mandatory slide in every single boardroom presentation.
Oh, yeah. The mandatory AI strategy slide.
Exactly. And every software vendor in your stack is currently emailing you to say that their new generative AI feature is going to, revolutionize your team's workflow.
They all promise the world.
They do. But if you actually work in the trenches of software delivery, you know there is a massive hidden problem lurking beneath all that hype.
A very expensive problem.
A genuinely shocking number of AI projects and heavily funded AI native startups are just completely failing. I mean, crashing and burning.
And they aren't just failing quietly in a sandbox somewhere, right?
No.
They are failing incredibly expensively. We are talking about millions of dollars in compute costs, completely blown project budgets,
Yeah.
and months, sometimes literally years of wasted engineering effort that just leaves teams demoralized and, honestly, their architecture's in ruins.
And that is exactly the mission of our deep dive today. We are going to unpack the real-world reasons why these failures are happening at such an alarming rate.
Which is so needed.
But more importantly, we want to extract the practical, realistic lessons to help you and your teams actually succeed where others are failing. We want to help you avoid these incredibly common traps and deliver solutions that actually work.
Real solutions, not just hype.
Right. No complex code or dense academic theory here, just practical reality. And to help synthesize this massive stack of sources, which includes startup postmortems, venture capital reports, technical debt analyses, I'm joined by our expert.
It's great to be here. And, you framed the mission perfectly.
Thanks.
We aren't just looking at the technical nuts and bolts of what broke. We are translating that into why it matters for everyday project leadership.
Exactly.
Because if you are the person responsible for managing a timeline or securing a budget, or even just protecting a team of developers from an impossible mandate, these failure patterns are directly relevant to the decisions you have to make this week.
Okay, let's unpack this. Let's start with what we're calling the AI reality check.
Let's do it.
Why are so many of these projects basically dead on arrival? I was looking at the venture capital numbers we pulled, and the surface level numbers are just staggering.
They really are.
In the first quarter of 2025 alone, AI accounted for 57.9% of all venture capital raised. Globally, that is $73.1 billion flowing into AI in just 3 months.
Which is a massive number.
It is. To a CEO reading a business newsletter, that looks like an unstoppable gold rush.
It absolutely looks like a gold rush. But when you look beneath that headline figure, that massive dollar amount is masking a very stark reality.
Okay, what's the catch?
Yes, the total dollar amount was record-breaking, but the actual number of individual AI deals dropped to a 5-year low.
Really?
Yeah. There were only 2,111 deals funded in that entire quarter.
Wait, so the pie is getting massive, but it's being sliced into fewer and fewer pieces.
Precisely. Much of that $73 billion was just eaten up by a handful of giant mega deals.
Like OpenAI.
Right. OpenAI had a massive $40 billion funding round led by SoftBank.
Wow.
Anthropic raised $3.5 billion. Safe Superintelligence raised billions more.
Yep.
So when you strip those foundational model giants out of the equation, the funding for everyday applied AI startups is actually drying up.
That consolidation at the top is wild to see. But why are investors pulling back from the broader ecosystem?
Because the failure rates have become impossible to ignore. The data reveals that roughly 90% of AI-native startups fold within their first year.
90%.
90%.
Yeah.
Gone in 12 months. And before enterprise leaders think they're immune, the numbers inside corporate walls are just as bad.
How bad?
95% of enterprise AI pilots fail to deliver any actual return on investment.
95%.
Yeah. They get stuck in what the industry calls pilot purgatory. They look great in a controlled test, but they never actually make it to production to deliver value.
If I'm a product manager proposing a new AI integration, those are terrifying odds. Why are they failing so fast?
Well, the postmortems point to a few massive problems right at the starting line.
Right. So let's get into problem one. the wrapper trap, which basically means no real business problem is being solved.
The wrapper trap is arguably the defining failure mode of the last 2 years.
Explain that for us.
A wrapper startup is essentially one that takes an existing, powerful AI model via an API like GPT-4 and just builds a thin user interface around it. They set up a basic system prompt, put it behind a paywall, and call themselves an AI company.
The analogy I keep hearing is buying a frozen pizza, putting it in a nicer cardboard box, and claiming you opened an authentic Italian restaurant.
That's a very apt analogy. But in an enterprise context, if we connect this to the bigger picture, the wrapper trap means your entire core value proposition is at the mercy of a third-party vendor.
You don't own the underlying intelligence.
You don't own the intelligence, you have no proprietary training data, and you aren't offering any unique workflow integration.
And the data shows this is lethal. 34% of these failed AI startups die specifically due to a lack of product market fit.
Exactly. They build the tech first because spinning up an API is so easy now, and then they go searching for a problem.
A solution looking for a problem.
Okay.
And this leads to what the sources call the Sherlocking effect. For anyone unfamiliar, the term Sherlocking comes from an old Apple software called Sherlock. Apple basically took the functionality of a popular third-party app called Watson, built it natively into the macOS, and killed the third-party business overnight.
And we are seeing this exact phenomenon happen in the AI space at light speed.
Because these wrapper startups have no defensible moat.
Right. A devastating example occurred when OpenAI held a developer day and announced native file uploads within standard ChatGPT.
I remember this. Before that update, there were dozens of startups whose entire business model was ChatGPT for PDFs.
You paid them $20 a month, uploaded a PDF, and queried it.
And the morning OpenAI made that a free native feature, all of those startups were instantly obsolete.
Evaporated. Their margins collapsed because users had absolutely no reason to pay a third party.
That's a nightmare. And for internal project teams, if your internal AI initiative is just a thin wrapper, maybe an HR chatbot, you might burn $1 million budget on something Microsoft Copilot is just going to roll out as a free toggle switch next month.
That is the exact risk, which leads directly into the second major problem. Using AI just because it's trendy.
Yes. Problem 2, shiny object syndrome.
The classic syndrome, but scaled up to an existential level.
Every delivery manager listening has suffered from this. The board reads an article about generative AI, and suddenly the mandate comes down. We need an AI feature in our Q3 release.
Driven entirely by FOMO, fear of missing out.
And marketing optics.
It leads to AI washing, labeling traditional software as AI-powered just to boost evaluation or secure funding.
And when companies push this too far, it leads to spectacular failures. The materials highlighted a London-based startup called Builder.ai.
A primary cautionary tale.
They reached a valuation of over $1 billion.
Backed by major players like Microsoft.
Right, and their pitch was they had an AI system that could automatically build software applications for clients.
The pitch was phenomenal.
Yep.
But the reality was a scandal.
What happened?
They filed for insolvency. It turned out they were accused of using armies of human coders based in India, manually working behind the scenes, literally posing as the AI tool.
Posing as the AI, it's the illusion of automation powered by human sweat.
They chased the shiny object of $1 billion AI valuation without the actual tech. And this happens on a smaller scale in enterprise environments all the time.
Teams claiming a feature uses machine learning when it's really just if-then statements. But the research points to a much darker side of this syndrome.
Yes, the layoff.
Using AI as a scapegoat for layoffs.
Highly concerning trend. Corporations are pushing this narrative of an AI revolution to justify mass layoffs. A CEO will announce they are cutting thousands of jobs, claiming it's due to AI-driven efficiencies.
But the reality on the ground doesn't match that at all.
Not even close. Economists and tech leads consistently point out that current AI tools are nowhere near mature enough to completely replace that human workforce.
So it's a cover story.
It's often just standard financial restructuring, dealing with high interest rates or pandemic overhiring. Framing it as an AI transition sounds better to Wall Street.
I can't imagine a worse position for a project manager. You survive layoffs, your team is halved, and you get a mandate to replace those workflows with an AI tool that barely functions.
You are set up to fail. It destroys internal culture.
Yeah.
Which brings us perfectly to the third problem causing these early failures: unrealistic expectations and the demo trap.
Problem 3, the demo trap. The research notes that 22% of startups fail because they spend millions building flashy demos that have zero practical application.
I've seen it so many times.
It looks like magic in a pitch meeting, goes viral, then it completely falls apart in a real enterprise environment. Why is that gap so massive?
Because generative AI is uniquely susceptible to being overly constrained in a demo.
Yeah.
There's a severe disconnect between the business leaders buying it and the technical realities.
Right.
In a demo, the sales engineer uses clean data, pre-written prompts in an isolated environment. The executive assumes it works perfectly out of the box.
They completely misunderstand the operational reality.
Real-world workflows are messy. Enterprise data is incomplete and full of contradictions. When the tool is handed to a line worker dealing with a convoluted database, the model hallucinates and the tool fails.
So to summarize section 1, if you start without a validated problem, chase a shiny object, and believe the magic of a demo will survive messy internal data, your project is statistically doomed.
That is the harsh reality.
Okay, let's transition. Let's talk about the architecture of failure. Here's where it gets really interesting.
The technical side of the failures.
Exactly. Problem 4. Overcomplicated solutions. Our sources highlight a very specific, very expensive mistake: building custom LLMs instead of using APIs.
This is a fascinating architectural trap. It's usually born out of a genuine desire to protect the company. Founders think, if we use the OpenAI API, we have no intellectual property.
So they decide to build their own.
They think they need to rent GPU clusters and train a custom foundation model from scratch.
It sounds logical. Own the factory, don't just rent the assembly line.
But the data shows this logic is deeply flawed 95% of the time. Training a model is an infrastructure play. It's astronomically expensive and requires rare talent.
The case study provided on this Voice AI Labs is eye-opening.
Oh, absolutely.
They weren't kids in a garage. They raised $12 million, had 45 engineers building enterprise voice assistants, and they decided to train their own speech-to-text model.
They thought off-the-shelf tools weren't optimized enough for corporate jargon. Let's break down the math on that.
Please do.
They spent 18 solid months at R&D building this custom model. Over that period, the salaries for their ML engineers cost $2.1 million.
Wow.
Acquiring and cleaning the specialized training data cost another $400,000. Renting the GPU compute power required to train the network cost $1.2 million.
So they burned $4.2 million over a year and a half just building the underlying engine.
Yes. And what would the alternative have looked like? An API-driven approach using Google's Speech API or OpenAI's Whisper would have cost them roughly $220,000 in usage fees over that same period.
That is a $4 million difference.
They wasted $4 million and 18 months of runway building infrastructure that was already commercially available for pennies on the dollar.
It's like deciding to build a hydroelectric dam to power the new light bulb you invented.
Exactly. Just plug the light bulb into the wall.
But the overcomplication trap doesn't end there. Even when teams use existing models, they overcomplicate the architecture, like the debate between RAG and fine-tuning.
We see this constantly. RAG retrieval augmented generation is incredibly popular. It's an open book test approach.
How so?
Instead of relying on the AI's internal memory, you build a complex pipeline. When a user asks a question, the system searches your internal documents, retrieves the relevant paragraphs, and feeds them to the AI to summarize.
It grounds the AI to prevent hallucinations, but what's the cost?
Massive complexity. You have to implement vector databases, chunk documents, maintain embedding models. It's a heavy, fragile pipeline.
And fine-tuning is different.
Fine-tuning is like having the AI study for a specific exam. You feed the base model a few thousand perfect examples of how you want it to respond. It internalizes the pattern. No search pipeline required.
The sources shared the LegalBot example. They wanted to build a tool for legal research. They jumped on the RAG hype train and vectorized 500,000 dense case documents.
Spent 8 months perfecting the architecture.
Yeah.
But their fatal flaw was failing to understand their users. Their users only ever asked about 200 common legal concepts.
So the massive search engine was totally unnecessary.
Absolute overkill. Maintaining that RAG system cost them $34,000 a month in cloud fees. And it took over 2 seconds to generate an answer.
2 seconds is an eternity in software, so they pivoted.
They tested a simple fine-tuned model on those 200 concepts. It took 2 months to build. It cost just $8,000 a month to host. And it returned accurate answers in 0.4 seconds.
$34,000 down to $8,000. That's survival right there, which bridges perfectly to problem 5. High infrastructure costs and negative unit economics. The silent killer. Inference costs.
Inference is where the fantasy of AI meets the brutal reality of cloud computing.
Right.
Training is a capital expenditure. You do it once. Inference is the cost of running the model every single time a user clicks submit.
And teams aren't budgeting for this. They think, let's just get it working first, optimize the bill later.
But with generative AI, inference at scale is an existential threat to the business model.
The DocuSign AI case study really illustrates this. They raised $3.5 million to build an AI contract review tool. They used GPT-4 but didn't run a proper token cost model.
A classic failure of unit economics. They plan to charge a flat fee of $15 per document analyzed. Based on light testing, they assumed the API cost would be about $2 per document.
Buying for 2, selling for 15. Great margin.
On a spreadsheet, yes.
Yeah.
But in production, users didn't upload 2-page NDAs. They uploaded 100-page merger documents. The context windows were maxed out.
So what was the actual cost?
The actual compute cost to process a single document in production was $45.
$45 to process a document they were charging $15 for.
Their gross margin was negative 200%. Every new customer made them lose money faster. Their runway shrank from 24 months to 8 months.
That is terrifying. But this isn't just an API pricing problem. It ties into the global hardware crisis, the scale paradox.
With traditional software, economies of scale mean your margins improve as you grow. Generative AI breaks that rule entirely.
Because it requires massive GPU compute power.
And we are in a global GPU bottleneck.
Yeah.
Data centers are consuming unprecedented electricity. Startups face 12-month lead times just to get enterprise GPUs.
Even OpenAI struggles with this. The leaked data showed OpenAI was projected to spend $1.69 on raw compute for every $1 earned in subscription revenue.
If the company that invented the market is struggling with negative unit economics, an internal enterprise team on a fixed budget needs to be extremely cautious.
What's the takeaway here for the delivery manager?
Absolute financial discipline. Demand a worst-case scenario cost per query analysis before authorizing the build. If the compute cost is higher than the hard business value it generates, do not build the feature.
Excellent. Okay, that covers architecture and economics. Let's move to section 3. The data crisis and the illusion of productivity. Problem 6 is poor data quality. The data tax.
This is where enterprise reality hits the AI hype. 43% of organizations cite data readiness as their top obstacle, and 41% of startups fail because they underestimate data quality costs.
The hidden cost averages $900,000 in an enterprise project, just to get internal databases to a point where an AI can read them.
It's garbage in, failure out. An AI model is only as intelligent as the data it was trained on.
If your data is a fragmented mess, the AI won't fix it. It will just confidently generate perfectly written, completely incorrect answers based on that mess.
The consequences go beyond wrong answers. We have to talk about bias. When models are trained on datasets that don't represent the real world consequences are severe.
Like the facial recognition example from the sources.
Yes, major deployments of facial recognition showed error rates of up to 30% when analyzing dark-skinned females.
30% error rate.
Because the training dataset was predominantly lighter-skinned individuals, the data was skewed, so the capability was skewed.
And in healthcare, predictive AI misdiagnosing minority patients because the historical data reflected white patients. It's a mathematical reflection of historical blind spots.
Exactly. Rolling out a biased tool is a massive reputational risk and destroys trust.
Which is a great segue into problem 7, lack of clear requirements and skills erosion. We've been sold this narrative of the 10x developer using AI coding assistants.
Oh, the CodeBridge study. What's fascinating here is the massive gap between psychological perception and measured reality.
Tell us about that study.
They tracked senior developers working in complex enterprise code bases. The developers felt they were moving about 20% faster using AI coding assistants.
But when they measured the hard data,
the total time from Jira ticket to successful production deployment was actually 19% slower.
That feels completely counterintuitive. The AI types out whole blocks of code instantly. How is it 19% slower?
Because software engineering isn't about typing speed. It's about architectural judgment. AI produces code with perfect syntax, but it lacks historical business context.
It doesn't know about the legacy security boundary or the weird date formats in the database.
Right, so the code fails during integration testing or introduces a subtle logic bug. Now the developer has to review and debug 50 lines of code they didn't write.
And reading someone else's complex code takes way longer than writing it yourself. They call this the effort heuristic.
Yes. Typing fewer keystrokes tricks the brain into feeling like less effort was expended. but they spent more cognitive energy untangling spaghetti code.
And this compounds into the 18-month wall. Walk us through the anatomy of hitting this wall.
Months 1 through 3 are euphoria. The AI generates boilerplate rapidly. You look like a genius.
The honeymoon?
Then, months 4 through 9, you hit a plateau. The code base gets larger. The AI suggests code that conflicts with older code. Integration challenges pop up.
Okay, so it slows down.
By months 10 to 15, things actively break. Adding a feature requires extensive debugging because the foundation was fragile. Human code reviews become a massive bottleneck.
And then the wall knits.
Months 16 to 18, feature delivery completely stalls. The code base is so unnatural and convoluted that the team no longer understands their own system. They are terrified to make a change.
The code churn data here is staggering. Code churn actually doubles in these environments.
Engineers aren't building. They are frantically churning out AI garbage and manually patching it. It's unsustainable technical debt.
And the long-term danger is skills erosion.
If junior developers rely entirely on AI for complex logic, they never develop architectural intuition. And senior devs spend all their time acting as bug hunters for the AI.
You end up with a team that can generate code fast, but can't design a stable system. Like relying on GPS so heavily you lose your sense of direction.
It's a critical risk to organizational capability.
All right, problem 8. No user adoption and the trust gap. Even if you navigate the coding wall and the data quality, none of it matters if humans refuse to use the system.
User adoption is the primary battlefield. Resistance is real, driven by job anxiety, but mostly by a profound lack of trust.
If an AI hallucinates a fake revenue number once, that employee will likely never trust it again.
It takes months to build trust and one hallucination to destroy it. And the trust gap with enterprise security teams is even bigger. Look at the MCP security crisis.
The Model Context Protocol, what exactly is MCP?
MCP is an open-source protocol that allows an AI model to securely connect to external data sources, like SQL databases or Slack, so it can retrieve context.
It gives the AI hands and eyes inside the enterprise.
But security researchers found over 8,000 enterprise MCP servers left completely exposed on the public internet, many with unauthenticated admin panels.
Anyone with a web browser could just walk right in.
And attackers did. In the Claudebot breach, threat actors accessed over 1,000 exposed panels. They extracted API keys and pulled highly sensitive internal credentials.
And they use prompt injection, right?
Yes. They feed malicious instructions into the AI agent, tricking it into extracting corporate data for them. The AI thinks it's fulfilling a request.
If I'm a CISO reading that report, I'm shutting everything down.
You can't blame them. If your architecture isn't secure by design from Sprint Zero, the CISO will kill your project before it reaches a single user.
Okay, take a deep breath. We've covered a lot of hard truths. The venture illusions, wrapper traps, compute costs, data nightmares, coding productivity illusions, and security crises. Let's pivot to section 4. The leadership roundtable.
I think this is a crucial step.
I am addressing you directly now, the project manager, the delivery leader listening to this. Let's debate some uncomfortable philosophical questions. Why do companies invest in AI without a clear goal?
I believe it comes down to FOMO, an intense pressure from boards and investors. A CEO sees competitors touting AI, sees OpenAI's valuation, and feels an existential dread.
They want to be perceived as innovative.
But this top-down mandate creates the learning gap. Tools are forcefully pushed onto teams without solving actual workflow problems. The teams never learn to use them, the AI never adapts, and the project fails.
So is AI sometimes used just for marketing?
Rampantly. Across the SaaS industry, vendors slap the AI-powered label on legacy platforms to justify price increases, but it's just a minor feature routed through an API.
But while vendors fake it, there's the shadow AI economy. What is that?
This is the ultimate paradox. Official enterprise projects fail at 95%, yet 90% of knowledge workers are actively using personal, consumer-grade AI tools to do their daily work.
Off the radar of the IT department.
Entirely off the radar. They use personal chat GPT accounts to draft emails, summarize transcripts, debug and code snippets.
So the workers want AI, the demand is there. They just want tools that solve localized micro problems.
Exactly. But IT tries to boil the ocean with massive, complex solutions that don't fit the daily workflow.
Obviously, shadow usage is a security nightmare, but it proves that if you solve a real problem, adoption is instant. Okay, next question. Can a simple solution be better than AI?
This is a question every tech lead needs to be brave enough to ask. The answer is a resounding yes. A simple, boring, traditional architecture is often vastly superior.
Why?
Generative AI is probabilistic. It's a prediction engine. It guesses the next most likely word based on statistical patterns. It is not deterministic.
It doesn't know facts like a database.
Exactly. If you are calculating sales taxes or routing inventory, a traditional relational database is infinitely better. Traditional software has predictable costs, takes milliseconds, and doesn't hallucinate.
And doesn't require a $150,000 cloud contract for GPUs, use a calculator for math, use AI for language. So when should teams explicitly avoid AI?
There are absolute no-go zones. Cryptography, security critical authentication, core infrastructure routing, the vulnerability rates are too high.
And compliance-sensitive logic.
Highly regulated industries like healthcare or finance. The EU's new AI Act imposes fines up to 7% of annual global revenue for violations involving high-risk AI systems.
7%. That could bankrupt the company because AI models are black boxes, right?
You cannot map the exact logical pathway a deep learning model took. If an auditor demands to know exactly why a customer was denied a mortgage, you cannot give a deterministic answer.
If you can't explain the logic step by step, you shouldn't use AI to make that decision. And avoid AI if you lack proprietary data because you have no competitive moat.
Exactly.
All right. We have diagnosed the disease. Now it is time to prescribe the medicine. Section 5. Practical lessons and steps for project leaders. So, what does this all mean? How do we build successful AI projects?
Let's open up the playbook.
Lesson 1. Start with a business problem, not the technology. The materials recommend a pre-build validation checklist. Instead of spending $1.8 million building the wrong thing, spend $16,500 validating the problem.
The goal is to shift the risk. Prove stakeholders actually care before authorizing cloud spend. Start with problem interviews. Map pain points.
And then the Wizard of Oz test. Pay no attention to the man behind the curtain.
Exactly like the movie. Build a basic front-end interface that looks like an advanced AI tool. But on the back end, a human being is manually doing the research and typing the response.
You fake the automation to test demand.
This tests if the user values the output enough to use it daily without spending 6 months building an ML pipeline. And you can also use a concierge MVP.
Which is similar but fully transparent. Send us your messy data. We'll format it manually.
If people won't use the perfect human concierge version, they will never use the buggy AI version. Validate demand through cheap manual tests first.
Lesson 2. Validate ideas early and use small prototypes. Avoid the mega model trap.
Assuming you need a trillion parameter foundation model for basic tasks is like using a supercomputer to balance your checkbook. Small language models, SLMs, are incredibly powerful.
The specialist versus the expensive polymath.
If you train an SLM purely on a specific domain, like classifying IT tickets, it can deliver 80% to 90% of GPT-4's performance at a tiny fraction of the inference cost and energy footprint.
And hybrid systems are recommended.
Combine a small, focused AI model with traditional deterministic rule-based software, plus a human-in-the-loop interface. Safer, cheaper, and faster to market.
Lesson 3. Test with small datasets and validate results. Establish rigid constraints early. Use architectural decision records, ADRs.
Before hooking up an API, the lead architect writes an ADR establishing non-negotiable guardrails, strict security boundaries, and data isolation requirements.
Like mandating that Tenant A's data can never be used to train the model answering Tenant B's queries, building concrete barriers before giving the AI the keys to a sports car.
It creates automated governance. It prevents a junior dev down the line from accidentally violating compliance rules just to ship a feature.
Lesson 4. Measure value and work with real users. Vanity metrics are useless. Our chatbot was engaged 10,000 times. Means nothing if they all click connect to a human.
You need the agent value multiple. Measure the hard financial value generated by the AI against the true computational cost of running it, a strict unit economics calculation.
If the AI saves $15 in human labor time, but the GPU cloud compute costs $45.
Your multiple is negative. The project is actively destroying capital. You must mathematically prove the AI generates more savings than it burns in server costs.
Lesson 5. Monitor performance and improve step by step. How do we avoid the 18-month wall of code collapse?
Abandon the idea that AI is a silver bullet you deploy and forget. Implement real-time automated quality gates. Track code health indicators continuously.
Specifically, defect density and code churn.
If you introduce an AI coding assistant and your code churn rate doubles, that is a massive red flag that technical debt is exploding. You are generating more code, but lower quality.
Implement pre-commit quality hooks to reject overly complex code, and ensure senior human engineers are always reviewing the architectural design. Gradual, monitored improvement is the only sustainable path.
The humans must remain accountable.
This has been incredibly enlightening and sobering, a pragmatic roadmap for project managers. To wrap up, I want to hand the floor over to our expert for one final provocative thought.
Thank you. I want everyone listening to step back and mull over this concept. We are rapidly entering a world where intelligence itself is becoming a cheap, easily accessible commodity via APIs.
Intelligence as a commodity.
Therefore, your ultimate competitive advantage is not the specific AI model you choose to lease. Those models will eventually equalize. Your true organizational moat is the unique, messy, proprietary human workflows and the exclusive data you own.
Wow.
So ask yourself this in your next planning meeting. If tomorrow every single AI foundation model became completely free and equally available to your competitors, would your project still possess unique value? If the answer is no, you aren't building a sustainable business, you're simply renting an algorithm.
If the AI was free, would you still have value? That is the ultimate litmus test. Thank you so much for guiding us through this incredibly complex landscape today. Your insights have been invaluable.
My pleasure.
And thank you, the listener, for joining us on this deep dive. If you want to dig into these venture capital numbers yourself, read the full postmortems of the case studies, and get access to all the links, please visit the full article on our website at datazen.top podcast-AI 17.
A lot of great resources there.
While you are there, please click the heart icon under the article. It genuinely helps us reach more leaders like you. Leave us a comment with your own project experiences, wins, and spectacular failures. And of course, make sure to subscribe to the Data Zen AI podcast so you never miss an update. Thank you for your time. Stay critical of the hype and keep building smart.
Goodbye, everyone. Take care.